Hi everyone, and welcome to Global Azure Norway. My name is Oddbjørn Bakke, and I'm part of the .NET user group in Norway who are organizing this event, and I will be your host for this session. If you have any questions during the talk, please use the chat to post them, and I will include them during the talk. And here's our speaker for this session, Heini Ilmarinen. So without further ado, the stream is yours.
Thank you. All right, perfect. Good evening, everyone. Greetings from Finland. It is so bizarre at the moment. It's so light out, but it's still already getting a bit later here. And I'm still kind of in the winter zone a little bit and getting used to it being so light out, but it's kind of exciting. So this evening in the session, we're going to be going into Azure Machine Learning and into how do you get from first building a machine learning workflow within the designer in Azure Machine Learning, and how do you take the steps into starting to use notebooks, and when do you do that? So that will be our plan today. So this is especially aimed for you if you're just getting started with Azure Machine Learning, you maybe haven't done anything with it, or if you're looking to get started in using the notebooks as well. So why all of us are looking into machine learning, it is because we have so much data nowadays. We have all different types, from photos to streaming data to more structured data and databases. And what we want to do to that data is, of course, in the end, get some kind of insights. But to start with, we need to do some cleaning and prepping to make sure that we can even trust that information that we get out of it. But the ultimate goal there, why we even do that cleaning and prepping in the meanwhile, is because we want to draw some kind of, start training some kind of algorithms. And from those algorithms, what we want to find out is we, for example, want to predict something. We want to be able to see ahead of time what could be the predicted outcome, and from that draw value for that data that we have gathered already. And luckily, we have some easy ways to get started. And one of those is the designer within Azure Machine Learning. And what that really allows us to do is to just drag and drop all these boxes that allow us to build the workflow that we wish to achieve, from just grabbing our data set, doing any cleaning and preparation that we need, then splitting that for our machine learning training, and then getting all the way to checking how good is this algorithm that we just built. And so we have all these possibilities to work with. And this means that it is really, really easy to get started. It doesn't take much effort. We just grab our data and roll with it. It is also extremely fast to build our very first pipeline. And we'll take a look at that in a little bit. And the nice part here is that we don't need any kind of code. We don't need to pick up a new skill, etc. But we do need to know, where do the limitations come in using the designer? How far can we go? And what would be the next steps to take after you have started working with the designer? So I'm Heini Ilmarinen. I have my old introduction slide here. I have no idea how I did that. But I work as a DevOps consultant at Polar Squad. I used to work as a solution architect around Azure. My favorite topic is pretty much still architecture, even though I do things with a little bit more of a DevOps twist nowadays. I also run Azure trainings. I am a Microsoft certified trainer, and I studied to become a math teacher. And so I'm a bit of a math nerd at heart, and all the logic that goes behind machine learning algorithms is really close to my heart and is an exciting topic in my opinion. And so, as you might have already noticed, I'm a bit of a doodler, and that's what we'll be seeing during this session as well as some hands-on portions as well. So to get started today, we're going to kick off by getting started with the designer in a very quick manner. So before we head on kind of hands-on and hop into Azure Machine Learning and start building our first setup, I just want to give you a little background. So when we start working with Azure Machine Learning, we have kind of 3 different options that we can start working with our data and start building our machine learning algorithms with. And so the first one of these is the designer within the Azure Machine Learning services. And this does give us that really easy to use graphical interface where we can drag and drop things and just choose the tasks that we need to do. But we also have the option of using notebooks. And these give us a programmatic way of working with algorithms, and it does give us more flexibility. There are more options for us to use with. And then lastly, we also have automated machine learning. And this is where there are these mechanisms built behind the scenes where it will run through different scenarios, and through that help us choose the right algorithm. But today we will be mainly focusing on the first two, and first starting off with the designer. And so we're going to hop right into it and build our very first experiment here. So let's go. All right. So I have already beforehand created a machine learning service in Azure, and you can go in and do that yourself as well. And we're going to launch the studio, which is actually a separate graphical interface to use from the portal itself. So it will direct us here. And right from the beginning, we can notice that there are these three different options to work with. We have the notebooks, we have the automated machine learning, and we have the designer. And we're just going to start with the designer because that is the easiest place to start. And it'll kind of get us accustomed to the process of building these machine learning pipelines. What are the steps that we need to do? So we're going to go into the designer. I'm going to navigate from the left here, and we are going to start a new pipeline here. So the designer experiments that we build, they are called pipelines within Azure Machine Learning. So when I create this, it automatically starts to ask me some questions. What kind of things do I want to use here? So I can give it a slightly better name. So let's do global Azure. And then it also asks me to select the compute target. So we have to select where does this run? And I have created one of these beforehand. This is a cluster that I specified earlier on, and I will show a little bit more about that at a later time. Also, if I wanted to set some parameters, etc., I could do that. But right now, this is kind of enough for me to get started. And so to get started with our experiment, the first thing we need to do is grab our data. What kind of data do we want to work with? And in this case, I have brought in already one data set, which is this open data set that is available to look into aspects of how can we determine whether someone is prone to having diabetes. So this is what this data set is telling us. And the nice thing here is right away when we have connected to this data set and dragged it onto our graphical interface, we can look at the output and visualize this. So we have this very easy way to get started and see what has this data actually eaten, what's in it. And once this opens it, I can see kind of a sample set of values from this data set. And I can see that we have age information, we have the sex, we have the body mass index, and then the rest of these values, they're not named very clearly. So to understand this, I had to go back to the information about the data set. And the rest of these columns are actually telling different blood measurements. So these are just different values that can be measured from the blood. And then as the last column here, we have the Y column, which is kind of a number that says how prone are you to get diabetes. So first of all, to start with any kind of machine learning, even testing around, experimenting, we should have some understanding of our data, because without that, it's kind of hard to even know what could we predict and which of the columns could we use to do that. And so in this case, we're going to start predicting the Y column because we want to predict, well, how likely is somebody to get diabetes based on these other values. And since I'm kind of starting off, I just want to grab all the columns, and then I could do some adjustments and test with the different combinations as well after the first results. But we're just going to start in that way. So here we have wrapped our data sets. So we have to figure out next what would be the next step to take after this. And so in a lot of cases, what we want to do is, for example, to select some columns. So for example, we have this data transformation section here where we can find different tasks that can be done here. And for example, I could clean some missing data. I could also, as I said, select some columns, and that's what I'm going to do in this case. And we're just going to drag it there. It gives us kind of this editor right away that we can use. It asks us to which columns we want to include. So we could do include all columns, but then exclude one of them. For example, by the name. And for example, I could just say S3. That was one of the columns. But in that case, let's just do the first run with all the columns. So I'll just have this as a placeholder to adjust at a later time. So right now it's choosing all of the columns. And then when I'm done with kind of the definition and configuration, I just drag an arrow to tell, well, grab the data from the first task and give it to the next step here. As the next step, we want to split our data because we want to have some of the data go into training our machine learning algorithm that we choose. And then we want to split the other part of the data to use as our test data set to then look at the scored model and check whether it's accurate or not. So I'm just going to put it so that we get 70% into the first data set and 30% to the second data set. And I'm just going to leave the other values as they are. And again, I'm just going to drag the arrow there. So then this first portion of the split data we want to take to our machine learning algorithm. So let's just, so we can see this list a little better. So we want to do model training. We want to train the model from this data. And here we need to specify the label column. And here it's going to be the column Y, which was the last column in our data set. We're going to save that. There we go. And we're going to just take this first data set and drag it to the training the model. And now we're kind of missing the other aspect of this training the model because we need to tell it what model are we training this data set against. So we're going to choose the linear regression here. And sometimes if you can't figure out like which category is it in, then you can just write in here linear regression, and it will tell you, give you some of those options. So when you choose linear regression in the designer, it gives you two options. You can use the online gradient descent or ordinary least squares. And of course, to know which option would be the best, you need to have some understanding of the different algorithms and the kind of data that you have. And then, of course, one option is to just test around and see what would bring good results for you. So we're just going to go with the kind of the default settings in this case. We're just looking to build our very first try here. Let's move that out a bit. And that is the other input that we're taking in to train our model here. And so after we have trained our model, the next step is then to score and then evaluate the model. So first we're going to score it. So that is where we are going to see whether the results that we have gotten from this training of the model, if that model that we got out gives us good results. So it will kind of calculate all those results that we would get. So we're going to drag that in there. And the other input that we need is the other portion of the split data. So that's what we're comparing against. And then when we've done those comparisons, then we can bring in the evaluation step. And again, we're just going to drag that in there. And here we actually have now our first pipeline. So we're bringing in some data, we're selecting columns. Here we didn't yet drop any, but we could in the future. Then we're going to split our data to the one that we use to train the linear regression model. And then we split it to the one that we're going to use to score the model. And then once we've trained the model, then scored it, then we're able to get these evaluations out of there. And so then we're ready to submit this. I'm just going to click submit. It's either going to ask us to select an existing experiment or create a new one. I'm just going to create a new one here. Let's do that. And on the first run, it can often take a little more time than in the future it will when you do subsequent runs on this. And it also depends on whether the compute has had time to shut down, for example, in between. So while we let that run, we can already see that it's going through the different steps and even saying that it has been able to complete, for example, the selecting of the columns, but it is right now starting to work on splitting of the data. And as it goes along, we're able to go through this and, for example, look at the different visualizations at the different steps. This is the very first one that we looked at. And for example, if we wanted to look at what kind of age values we have, it will give us all of those kind of central tendencies of what is the average, what is the minimum and maximum, etc. And we'll have kind of more information about how our data is spread. And one kind of essential information here is also the missing values. So we know that we actually have no missing values in this column. And if we were to click through all of these, we would actually see that none of these columns have any missing values. So we know we don't need to handle those in any way, which in a lot of cases we might need to even. So that's going to take a little time to run. So we're actually going to take a little shortcut. I have a previous run here, there, and we're going to look at the results here. So it's pretty much the same setup. I had a clean missing data step in here as well, but as you could see, we weren't missing any data in the first columns, and I checked all of them and there was none missing. So pretty much the previous pipeline was the same as this one. And so now as we're going in through this, now if we look at actually the train model step, we can actually see that this will output a trained model. So this is actually the step that outputs the specific model that we have created. That's where the output comes from. And from that output, using that one and the other data set, we are now able to look at the scored data set here. So we can see that it looks very much the same as previously, but in addition to the regular columns, we also see this scored labels one. And this is showing the predicted value for the Y column. And if we kind of just eyeball through that, we can see that, yeah, some are somewhat close, like these ones, but some are kind of quite far away. So there is some kind of variation there. And just by looking at it, we can see, well, some are closer and some are quite far away even. So it might not be our best attempt yet, but to really know how good it is, it makes more sense to look at the model evaluation. And then there we can, for example, find the mean absolute error and the root mean squared error. So these are the different ways to describe how far away are the values from the actual value of the data. How far away is the predicted value from the actual value? And this is in the kind of, we had that Y column value, so it's like 53 away from the actual value on an average. So that's kind of what that is telling us. And To understand really what that means, we need to, of course, understand about that y column. How big of a difference is that? It depends on the scale of that number system that is used in the y column. And unfortunately, I don't know those exact details. So we would, for example, need to go back to somebody who is the subject specialist to learn more about that. And we have also these other values here. So the relative squared error is 0.42, for example, and the absolute error is 0.61. So that's our results. We have built our first designer pipeline here, and our running one will be done shortly. But in the meanwhile, we're going to continue on to the next topic. So starting with a designer was quite easy. We could just drag and drop. It was kind of intuitive as long as we kind of know what are the steps that we need to go through. But for example, when we were choosing that, starting to run that pipeline, it, for example, told us that we need to choose a compute, we need to specify a name for experiment. So it's kind of telling us certain things in advance. So yes, it's easy to start quickly with a designer. But if we want to start working towards using notebooks, we need a little more information. And so next we're going to look at an overview of Azure Machine Learning to understand how all these different concepts fit together. What are experiments? What is the compute doing? What are these different methods? So next we're going to go into that. Sorry about that. So if we think about Azure Machine Learning, so we have these three different ways that we can work in Azure Machine Learning. We can use the designer, we can use the notebooks, we can use the automated machine learning. And there are some differences between these different options. The designer we can only use within Azure Machine Learning itself in the graphical interface because it's kind of a tool set that is built in there. But for example, to work with notebooks, we can use work actually from our local computer. We can even use Azure Machine Learning from Synapse Analytics. If you were listening to the previous session, that was mentioned there. And also with the automated machine learning, we can work with that from different places. And that is due to the fact that these work through the Python and our SDK. So in whatever environment where we have those available, we're able to work with Azure Machine Learning as well. So we can set up a local development machine to work with Azure Machine Learning, and then it's even possible to run our experiments locally on local compute as well. So we start with these three different options to work with our data. And of course, the first thing that we need is some kind of data sets that we're going to pull in. And one aspect of Azure Machine Learning is that we can define different kind of data stores and data sets. And the data stores are pointing to things like Azure SQL or Azure Storage or external databases from things that aren't within Azure, but it's kind of a pointer to a specific data store. And when we do that pointer, when we set that within Azure Machine Learning, then the people who are working within Azure Machine Learning can also discover the data sets that can be found within there. And then we're able to also define these data sets, such as was this diabetes data set that we were working with in the example. That was defined as a data set in the Machine Learning Studio. And when we have that, it means that we can use that data set, that same exact data set in different experiments. And that allows us to ensure that everybody's working with the same data. It's not that somebody was able to pull a different set of data and another person pulled a completely different set. So we can have kind of these predefined sets of data within our Azure Machine Learning environment. And so when we pull that data into our designer pipeline or into our notebook, then when we define what we're going to do with that data, we need to run that somewhere. We need to have some kind of compute underneath where against which it will run that experiment. So for example, for the designer pipeline that we just walked through, we had a compute cluster that it was running that whole thing against. And then as we go into our notebook in the next step, you will see that also for that, we need to specify a compute that we're running it against. And as I already mentioned, if you work locally with Azure Machine Learning notebooks, well, actually there are Jupyter notebooks, but if you're working with Azure Machine Learning with the notebook portion, then you are able to even run that notebook locally on your local environment. And the same with the auto machine learning as well. That can be run anywhere, but we need some kind of compute to run that on. And we can have those definitions within Azure Machine Learning. And this includes both the parts where we're training our model, but also when we're deploying it. So we can also define those deployment destinations where we want to take our model that we got out of our training, and we want to actually publish it and have it used in our application. So, but when we're in the training phase, what we then want to do after we have all the steps in place and we have defined where will this run, then we will actually run that specific one, and this is called an experiment. So you saw that already when we were defining the designer itself. So those are the kind of the main components that is in there. There's more detail to all of this. So if you're interested, start digging more and finding out more about the different options. But those are kind of the components that we need to understand to be able to start working with the notebooks in a more efficient manner as well. So if we just take a look back at the designer that we worked with, yes, we can, if we go to the experiment section here, this is what we are running. We can now see the global Azure Designer experiment here. And now we're able to go to all the runs that have gone underneath it. And if I were to make adjustments and run it again, I could see the different results and go back to them. So I can just click this run, and I am now able to see the results for this specific run as well. And I could, for example, go directly to the evaluation, which is actually still running. It's just in the finalization stage and will be done in just a moment. So you saw that's about how long it took to do that. But also what we were using here was compute. So here on the compute portion, we can find compute instances and compute clusters. And what we were running this against was actually the compute clusters. So this is what this particular designer pipeline was running on. And as you can see, one of these nodes is currently busy. So it's running our pipeline that we started a moment ago. And then the third portion here that we were using was the datasets. Here I had registered this beforehand, but we can create our own datasets from either just bring local files and get started really easily. We can use the data stores that we have defined. So for example, if we have the pointer to our Azure SQL, we can pull different datasets from there. We can grab some web files. And then the particular dataset that we were using is from one of these open datasets. There's quite many of these available here. So these are a good place to get started if you don't quite yet have your own data to work with. So you can just define one of these into your workspace as well. All right, but we are going to use all of these concepts as we start moving towards the notebooks as well.
So
here.
We have a question. What's
Perfect.
the difference between compute cluster and instance?
All right, so that's a very relevant question. So a compute cluster is where we're able to define a cluster that will have multiple nodes running. So then if you have a kind of a more complex machine learning algorithm and the model that you're training is complex and needs a lot of compute, then you can have a cluster and that workload can be spread out on that cluster kind of more evenly. And then when you have a compute instance, that is just one node. So that's the difference there. Perfect. All right, and perfect timing. So that is kind of the overview of the different components. And now that we understand these a little bit, it's going to be easier to get started with the notebooks as well. So as the third part today, we're going to get started with our first notebook. So as said, we will move on to the second portion here. And so we're going to get right to it here. So I'm going to switch over again. And I have kind of done a little bit pre-prep, so we have a little more time to really focus on the kind of details and why we're doing each point here. So I have created a notebook beforehand. We're just going to navigate to our notebooks. As you can see, you get kind of your own folder where you can create your notebooks, and you can even share these with different team members. And so you can share the notebooks however you wish to. And so as we're starting to work with notebooks, if you haven't worked with them before, they're kind of this nice combination where you can combine both documentation, because you can have these text blocks as the first one here, and you can combine these code blocks as the second one right here. So, and as also when we open this, we can see that, yes, there is also a compute virtual machine here that we're running on. This is now the compute instance, so it's just one virtual machine. And since we're working with the notebooks, that virtual machine will have all the tooling in place that we need to work with. So it has all the tooling that we would need to put in place if we instead were working with on our local computer, for example. So I can actually show that pretty quickly here. So if we just take a quick look at the compute instance that we had connected there, we can see that there's Jupyter Lab, Jupyter, VS Code, RStudio, and the terminal installed as applications on this particular virtual machines. And so that means that we have all the tooling in place that we're going to need. So now we're going to start working through kind of trying to find the same steps as we did in the designer as well. And actually, in this case, we have to take a few steps back, and we need to start from actually getting the workspace configuration and connecting it to the workspace that we want to work with. So that's where we're going to start. My compute here is already started, so I can start running each of these cells one at a time, and I can even kind of click through the text fields as well. So if you haven't done this before, you can just use Shift-Enter to navigate, and that will run the code blocks, and it will just kind of skip the text blocks instead. So in this first block, I am going to use some of the Azure ML Core libraries to be able to connect to our workspace and do the interactive authentication in there. Now, since I'm already in this workspace, it's not actually working locally, it would ask me to sign in. As the second step, one of the steps that kind of came easily in the designer, we just typed in the experiment name, is that here we need to either connect to an existing experiment or create a new one. So I don't actually have an experiment for this one yet, but it would kind of notice if I gave a name that already exists, and I could just run it again in that way. So I'm just going to run that, and it will create that experiment in the experiments set. Next, I am going to connect to our data set. Here again, I'm going to not actually use the data set that we had defined within our Azure Machine Learning, but I'm going to directly connect to the open data sets. So again, I'm going to use the Azure ML Open Datasets library, and within there, I can just import the diabetes dataset by referring to the diabetes dataset with the import. So I'm just going to get that tabular dataset and import that into a data frame. So that's what I'm doing here. And so what you notice here is that the coding itself isn't very complex. We're not doing selects or anything like that to get things, but we need to know which of the libraries we need to reference to be able to run these actual code blocks. So for example, here previously we needed aspects from the Azure ML.car, and here we needed the open datasets as well. And now that we have imported this diabetes data into a data frame, we have different ways in which we can kind of figure out what kind of data we had. So in the designer, we had that nice graphical interface, and we could see these graphs and see different values about it. But here we have to work a little differently. So just to figure out how many columns we have in general and what kind of values there, we can run the info query. So there we see that we have the same columns as we saw before, and we can see the different types. So we have some integers and also some decimal numbers as well. But if we want a little more information, we need the describe here. So this is where we kind of get similar to what we got before. We get the mean value, we get the standard deviation, we get the minimums and maximums, and also how the data is spread out. And so we get a little more information. And here we can see that all across we have 442 rows. And if we go all the way to the right, we can see that that applies everywhere. So I'm going to scroll this up a little bit. All right, so now we are able to get a general understanding of our data. So out of the box, we don't get any nice visuals. If we did want that, there would be ways to do that as well, and libraries we can use to make that work. But just because we have a bit of restricted time today, we're not going to go into that detail. So next, we're going to start prepping to split our data. So next, what we're going to do, we are going to create two data frames, the X data frame and the Y. And into the X data frame, we're going to take the entire data set, and then we're going to take the Y column from the X data set and move it to the Y data frame instead. So that has been done. And just to ensure that that's actually what happened, we're just going to run the describe again against the X data frame, and we can see that we have all those columns.
Sorry.
Yes.
Is there something wrong with your picture? We get a question here that there might be the wrong picture on the screen.
Yes, you have the wrong picture on the screen. I am so sorry about that. Thank you for pointing that out, and I apologize. Two screens, first time I've done that particular mistake. All right. Okay, how much time do we have? All right, I'll do a little recap of what I was trying to show you, because apparently that was not moving. So in the first portion, we're connecting to the workspace. I'm just gonna hop over here and we're going to run through these blocks one by one really quickly. And so you know what I was showing previously. So again, we're going to use the Azure ML.core libraries and connecting to our workspace. We're then going to connect to our experiment that now actually already exists because I ran this previously already. Then we're going to get the data set from the Azure ML Open Datasets. Then I'm going to make this just a tad smaller. We're going to get the diabetes data frame info, which is actually this one. And then we ran the describe, where we got much more information actually. So this is where we get all the means and standard deviations, etc., for all the different columns. So this is kind of the similar that we were able to get from the visualize step in the designer. And then this is where we kind of got to the fun part, where we actually split this diabetes data frame into two. So we did the X data frame and the Y data frame. And if we kind of double check with this X one, we can see that we no longer have the Y column there. So we have all the other columns but the Y. And then when we just, oops, this is popping kind of weirdly. When we run the describe on the Y data frame, we notice that we have just one column where we get all this information from. So we again get the means, etc. So then we need to split our data into the training and testing data set. And this was pretty easy in the designer. We just dragged the split data task and just put in what portion we wanted to do. But here we are going to leverage the scikit-learn library. So that is one of the libraries where you can find a lot of the things that we're going to need for machine learning tasks. We're going to find this train test split, and in the next steps, we're going to, for example, grab the linear model one, and then some of the metrics that we're going to need to be able to evaluate whether this model is working well. So we're going to do the splitting of the data, there's this train test split that we can use, where we give the training data set, the testing data set. No, wait, sorry. I got myself confused with this screen thing. So we give what we're going to split this into is these 4 sets. So we're going to get our X training set and our X testing set, plus our Y training set and Y testing set. And the X here is going to contain all the columns that we're using to train the model. So it's going to include several models. So that is actually going to be a matrix format. So if you're interested, you can look into that, what that means. But it's going to include all those columns. And the Y sets are going to only include that one column. So to do the split, we're just going to input the X data frame that we already created and the Y data frame. And then we're going to give it how large do we want the test size to be. And here we want to use 0.3. So in the designer, we told it to give the first data set as 0.7, so 70%. And in that case, that was the data set that we took to do the training. But here we're specifying the size of test data set. So we take the 30% instead, so 0.3. So we're going to run that. As you can see, that was a fast task. And then next, we're going to grab the model that we want to use, and then we're going to train that model. So in this case, we're going to use a linear regression model. And here kind of comes the difference between the designer and using the notebooks. So within the designer, we had just 2 options for different linear models that we can use. But actually in the scikit-learn library, we can use many, many more options than just those 2 for this case. But we're just going to go with the basic linear regression as we did in the designer as well. And so in this first line, we're here going to just specify what is the regression that we're going to use. And then to train that, we're going to use this fit where we specify then the data set that we're going to train, and then the results of the Y column that were in our data already. So we're going to give them both the X and the Y values. And then after that, in this next step, this is where we score the model. So this is where we give it the test data set, and we're going to see what does it actually predict out of there. So let's run this. Didn't take long at all, again, as we could see. And then as the last point, we need to get some kind of similar information as we got in the end of our designer as well. How good is this model that we created? So we're just going to grab some of the coefficients that are easy to get out by default from the library. So the mean squared error and the R2 score. And so we're going to get the regression coefficients. So these are going to tell what our algorithm is like actually. So these are the values from there. The mean squared error is telling us one of the similar values as we could find in our designer. So I'm just going to show you the comparison in a little bit. And then we have the coefficient of determination here as well. And so I'm just going to grab the designer out real quick here. And we're going to grab the one that we ran in just a little bit ago. And if we go into the evaluate model section, we can see here that it gave the root of the mean squared error. So here we got the mean squared error instead. So we would need to take the square root of this to have the same value as we had there, but this is actually a little bit over 50 as well, 52, 53, somewhere there. So we're very, very close to getting the same answer. And here we have the coefficient of determination at 0.52, whereas here we have it at 0.56. And where these differences can come from is because we're splitting the data, and actually the designer and the notebook can be splitting the data a little differently because there's some randomness to it. And the other aspect is I didn't go into all the little details to ensure that they are like exactly to the point the same. but we did have all the same, very similar steps in here. And as you can see, we got very similar results as well. So we have actually now gotten to a point where we have been able to build our very first notebook here. And so what we really were doing as we were working through that notebook is that we were kind of looking at each step at a time. So if we, for example, take one step out of the designer as an example, the split data step here, and we think about how do we do this in the notebook? Well, in the notebook, actually, we needed to take 2 steps. It wasn't just one easy step. So we first split the data frame itself. So we had the data frame where we have the columns that we're using to train the model, and then we have the data frame where we have the value that we're trying to predict. So we did that first. Those are the 2 first lines here. And then as the second portion, we had the actual splitting of the data, where we needed to have both of these data sets separated already to be able to do that split. So kind of, if we work starting from a designer, it actually allows us to understand the phases that we need to have within our notebooks as well. And we can use it as a comparison of like, have we done all the things that we needed to do within our notebook to get the results that we wanted. So that can really help us work as well. So it's not a bad place to start with the designer. So that's pretty much why we started today with the designer. We kind of put together a simple pipeline where we use the linear regression to determine, to predict this value of y in our data set. Then we took an overview look at Azure Machine Learning so we could understand the compute and the experiments and the data sets that we can use in our notebooks as well. And lastly, we then wrote actually our first notebook. And it wasn't that many lines of code, but yes, there are some things that are more simple in the designer, like the visualization aspect. And there's some steps that are kind of even easier within the notebooks, like the training itself. It's just 1 line of code, and that does the trick. And even we could see that it was really fast, faster than in the designer setup. So now that we've gone through these 3 different steps, the next time you go ahead and grab your data and you start working with it, you want to start doing some predictions. You're able to start doing the cleaning just as well in the notebooks as in the designer as well. And when you're getting to that point of training your machine learning model, then to get those insights, you have now an idea of where to go to make those steps within notebooks as well. So I really hope you enjoyed this session and it kind of gave you the first steps to get started with to start moving towards using notebooks as well. As said, Designer is a great place to start with, but you have less algorithms to use, for example. So there are the most common ones in there, but you don't have all the expansiveness that you have within the notebooks and leveraging the different libraries that are available. I also wanted to point out that during the Global Azure event, there is this 30 days to learn kind of campaign. And if you want to take part, there is actually a data science track where you're going to get a chance to build machine learning pipelines. I'm not sure if it's just the designer or also the notebook, but if you want to get deeper into this topic, it will be really kind of a good place to start where you'll have kind of these learning tracks that you can use. So grab those links and get started, and you can get this learner badge by completing one of those only word coming to my mind now is experiments, but I don't think it's an experiment. But you can complete one of those tracks that is available on that page, and you have 30 days to complete it. So thank you so much for joining. If you have any questions, now is we have some time for Q&A. And if you have any further questions after that, you can also find me on Twitter as well. So thank you for joining.
Yes, we have one more question here from Mitesh. Giving you real-world experience, am I correct to state that small, medium-scale companies generally use notebooks for machine learning?
Yes, I have to say I haven't seen much designer setups used in full-on production mode. So as you could see, like the designer setup we had took quite long to run, but the notebook code blocks, the training took like 1 second to run. So that speed difference is something that's there. But also if you're starting off with the designers, you can kind of get those experiments in really fast and kind of just figure out, can I even do anything with that data? So it's kind of an easy, fast starting point. And then you can kind of, once you've figured out what you want to do, then you can kind of take that over to the notebooks as well. So yes, notebooks are more common, I would say.
So there's another question from Mitesh. I am new to Python, R, and Scala. Which language do you recommend I learn, or what language has the least learning curve?
So as mentioned, within Azure Machine Learning, there's the Python and R available. So from that perspective, I would say Python or R. And with least learning curve, this might also be a bit of personal preference as well. But in my opinion, Python does have a bit of a less of a learning curve. So R is very full on like data science, deep in it type of language. And Python is something that is used also in other contexts rather than just machine learning. So it's also kind of useful to other coding areas as well. So it's not the only place you can use it. So I would say start off with Python. It's kind of easy to get started. There's the libraries that are available there are really useful and powerful. So it's a good place to start.
Yeah, and then I don't think we have any more questions.
Okay, perfect.
So, it's an interesting talk.
Yeah.
Thank
it
you.
was fun.
Yeah.
And thanks for chatting about the screen share. That worked out fine in the end. So
Yeah.
all right.
Yes.
Thank you, everyone.
Last question.
Oh, last question.
Mitesh now also. Any good books you recommend one should read to understand generally used ML terms?
Yes, if I could just remember it right at this moment. There are good machine learning books out there. I think I can pop into the YouTube channel and write that in the chat in a moment because I can't remember off the top of my head. So that might be a good solution here.
That would be great.
Perfect.
Yes. All right.
Nice.
Yeah.
Thank you so much for doing the questions during the session. And thank you for having me. It was a great to be part of this.
Yeah. Thank you so much, as they're saying. So very helpful. Great.
Perfect.